Today's lesson, scientific notation. Before viewing this, I highly recommend that you go back and you watch my video on significant figures and identifying them, as you will need to understand significant figures in order to properly write scientific notation. Scientific notation is designed to be a system to write very large and very small numbers in a quick amount of time. So if I wanted to write the number 1 million, I need a 1 and 6 zeros. And 1 million is not very large, but eventually this number can get big enough if I go to a billion and then eventually a trillion. Writing all these zeros becomes tedious, and scientific notation is what allows us to write these numbers in shorthand. So, starting with the number 1 billion, let's figure out how to write this in scientific notation. Scientific notation is in the general form A times 10 to the B, where A is a number between 1 and 10, and it must be less than 10. So I want to look at 1 billion and I want to ask myself, where can I put a decimal point to make this number between 1 and 10? Well, I can put it right here. So my A is 1.0 times 10. And my B is the number of decimal places I need to move to return to this full number. A negative B would be telling me to move my decimal point to the left, and a positive B would be telling me to move my decimal point to the right. So let's think. If I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 billion in scientific notation would be 1.0 times 10 to the positive 9. Now, let's do a few more examples to make sure we have mastered this skill. The number 172. 172 has 3 significant figures. These are all non-zeros. And I need to write a number that includes all of them that is between 1 and 10. Well, I can do that by writing 1.72. Now, times 10. And for my B value, how many decimal places do I need to move this decimal to get back to the original number? I need to move it 2 places to the right. 172, written in scientific notation, is 1.72 times 10 to the 2. Now, for a small number. .050 has 2 significant figures. It has the non-zero 5 and the trailing 0 with a decimal point. So I want to write all of these significant figures in a number that is between 1 and 10. 5.0 times 10. And when I'm thinking about my B number, I need to think, how many decimal places do I need to move this to go back to my original number? 1, 2 places to the left. So this is going to be a negative 2. Let's try 2 more examples, right? And these each I'm going to give you time to work on your own. The first is 100.6. Write 100.6 in scientific notation. Pause the video, and when you are done, continue for the answer. 100.6 has 2 non-zero numbers and 2 sandwich zeros for a total of 4 significant figures. I can write these 4 significant figures as a number between 1 and 10 by writing 1.006. Now, when I'm thinking about my b value, if my decimal is here, how many places do I need to move it to get back to my original number? 2. To the right, so this is a positive 2. Final example. .0.0006. Please take a moment to write this in scientific notation, pause the video, and resume when you'd like to hear the answer. 0.0006 has one non-zero number, and it has only leading zeros, which are placeholders. These are never significant. So my a value is simple here. 6 times 10. And how many places do I have to move my decimal to get back to my original value? 1, 2, 3, 4. To the left, so -4.